Today we're going to learn about linear regression. Here's the warm-up. Please give it a shot. If you need more time, please pause the video. Alright, so the warm-up says, the scatter plot and the line of best fit show the length of 12 peoples. That's supposed to say femurs, so make sure you're going to cross that out. That's femur, the long bone in the thigh, and their height in centimeters, right? So if you're just reading this along our x-axis, that's going to be how long your femur is, and along our height is going to go up, right? Based on the line of best fit, what would be the predicted femur length for someone with a height of 218 centimeters? Okay, so we are given the height, right? So we're trying to figure out our question is, what would the predicted femur length be? Okay, so what we're doing now, and we're told 218, our height is 218, so I'm going to go ahead and go 218. We don't have it on here, but we can start by making a table, and it's not on. You can see that my graph only goes to 214, so we need to go beyond our graph, right? So I'm just going to write the last couple and see if we can figure out our slope. Okay, so we're going to pick from these points here, right? So we have 57, 60. Given to us, we have 60 and 197. And we have 63 and 204. Okay, so it's our slope is going to be the same. So our run is going to be +3, and our rise is going to be plus 7. So our slope for this line is going to be 7/3, or we can keep this pattern going, right? So if I'm going along the x's, we'd have 66's next because we added 3, and then we have 69, and then 72, and in our corresponding y's, we keep adding, so we'd have +7 over here would be 211, and then we add 7 more, so we'd be at 218. Okay, so this right here, we're going to stop here because again, we're trying to figure out the height at 218 centimeters. My height is at 218 centimeters, so the corresponding femur length would be 69 centimeters. So we'd say 69 centimeters for our femur. All right, so if you go down to that page for our notes, these are everything you need for this section, okay? So our linear regression, basically what a linear regression is a statistical method to analyze the relationship between two variables by creating a line of best fit, okay? So that line you've been given in some examples, we are going to now be able to create it ourselves, okay? And when we are looking at it, we're going to be given an R value, okay? When we get to the Desmos portion of this, I'll show you where you can see the R value, but our R values are going to go from -1 all the way to +1, okay? So, and those are going to correlate to what we see as either a really strong negative correlation or a really strong positive correlation, and everything in between, okay? So if we were to use these pictures here, right, if I would say that our strong negative would be anywhere like a perfect straight line would be R equals -1, and right here at strong negative, I would say this is like -0.9. Same thing over for strong positive, right? Instead of being a negative R value, my R value now is going to be like at a 0.9, okay? Not quite at a 1, because if it was 1, it would be completely in line like this. Same thing over here, right? You have a straight line of dots. So then this would be like a weak correlation would be like 0.4 and -0.4, and then no correlation would be at 0. Okay, and then what you're going to need is this formula right here. This is one way to use this when we go to Desmos. This is what's going to happen. This is what we're going to type in. Let me go to the laser. This is what you're going to need. Y, a tilde. So basically you're writing the equation for a line, but we're going to replace the equal sign with that symbol there. And I'll show you how to find that. How I want you to write it in Desmos is actually this. So instead of Y, you're going to write Y1 tilde M x1 plus b. Okay, so make sure you write this into your notes, and this number is going to depend on the table, and you'll see that when we get to Desmos. Okay, so first example on our linear regression notes is we just want to determine the type of correlation represented in the scatter plot below. And we have two of them, right? We have our first one and our second one, okay? So if you look at the first one, you notice how in general we have a pattern that's going in a positive direction, but it's pretty weak. So I would call this and all you have to do is describe it. So this would be a weak positive correlation. Okay. And then over here, notice like this one's pretty obvious, right? So we're going down like this. So our correlation would be a strong negative, because we have a negative slope. Whoops. Negative correlation. Okay, and that's example 1. Example 2 is going to be looking at the actual equation for a linear regression. So it'll state something like, which of the following regression represents the strongest positive relationship between x and y? Okay, so for each regression, set of regression, we're given a equation. And what you're going to do is you're going to take the letter, so like a goes at a. So our equation for regression 1 would be y equals 10.6 x plus 19.5, and our regression number is going to be 0.4601. Okay, so obviously remember our numbers are going to be between -1 and 1. Anything that's like less than 0.8, I would say it's not a strong relationship. So this would be this would be an example of a weak positive relationship. Same thing here. For just this one, I'm just looking at the R values. Right, so this is going to be a weak positive equation. Here, again, this is our relationship. So this is going to, in our y-intercept, our slope is negative 9.7, and this is going to be our y-intercept is negative 16.1, okay? And this is going to be a weak negative correlation. If you look at regression 3, we have a strong, because this is the number we're looking for, a strong, because it's pretty close to 1, a strong positive correlation, and we have a really strong negative correlation here. Okay, so between these numbers, which one has the strongest positive linear expression, right? Well, in this case, it's going to be regression 3, right? So it's going to be regression 3 is going to be our answer here because it is the biggest R value. Okay, so which of the following regression represents the strongest negative linear relationship between x and y? Again, we're going to look at, I'm going to do this in blue, we're looking at R being negative 0.9 because that is out of all 4, that is the weakest negative, the strongest negative, strongest, so the closest to -1 linear regression. So it's going to be, we're just going to say regression, regression 4, and I forgot to write 3 here. So regression, let's try that again. I can't spell. Regression 4 and regression 3. For the last example that you're going to see is you're going to actually use a linear regression equation in Desmos. So at this point, please set up a split screen in Chrome so you can see your Delta Math problem and your Desmos window right next to each other. It's going to make your life a lot easier. The first thing we're going to do is we're going to create a table. So there's a couple ways you can do this. You can type out the word table, T-A-B-L-E, and notice how the moment I press the letter E, it creates a table for us. Or I'm not going to exit out of this, or you can hit plus and hit table from that plus button, right there. Okay, so what we're going to do is we're going to take these values, this table, and just plug it in, right? So we're going to write 0 here, and my first y is going to be 85. And then we're going to go down to 1 and 86. And then we're going to have 2 and 3 and 4. 24 for our x's, and then we'll have 96, 152, and 172. Now, notice we have a magnifying glass with a plus button inside. If I press that, it'll zoom in so all our points are visible, right? I can zoom, I'm going to move this over just a little bit because I need more of the calculator now. Okay, so there are the 5 points that we graphed. Okay, so what you're going to do, just like we had in our notes, I'm going to go back to the page in our notes. I'm going to use this button here. Okay, so notice how in my table over here, the top of the table says x1 and y1. We want those variables to be in my equation. So if it says x1, x2, and y2, you're going to write x2 and y2 and not what I have here. Okay, so let's start with y. My y is 1, so I'm going to just write y right next to it. It will call everything in that y list. Okay, so from here, you can either hit shift and the top left key on your keyboard, or you can go to ABC, and your tilde would be 2 buttons from the left for my blue button right here, right? It'll look something like that. Then we have the letter M, and then we're going to go X. 1, because again we're calling all my x variables. We're going to go plus b. Okay. All right, so you're going to be given a lot of points, right? So our slope for the line, if we is going to be 24. So for every 1 to the right we go up. For every x we increase, my y is increasing by 24. My y-intercept is going to be at 70, and you can see that in the line on my linear regression. And then our R value, that is the one we're looking for. Okay, so in this case, our R value is going to be 0.9294. Okay, so what it's asking for is the annual profits for a company are given in the following table. We put the table in there, where X represents the number of years since 2014. Y represents the profits in thousands of dollars. Write the linear regression equation that represents this set of data, rounding all coefficients to the nearest hundredth. Okay, so let's start by writing the equation. So we have y equals, we don't have to we don't have to write it using the tilde. I want you to actually write the equation now. So my slope, we already said, was 24. Then we have x plus 70.2. All right. So we thankfully don't have to round anything because the nearest hundredth, we already are at whole numbers and tenths. Okay, so don't have to round any more than that. Using this equation, find the projected profit in thousands of dollars for 2025. Okay, so now this is where we have to really think through the problem. Remember, 0 represents 2014. So 0 equals 2014. 1 is going to represent 2015. We need to go all the way to 2025. Okay, so we are looking at 11 years. So if 0 is the first number, we're looking at x being 10. Okay, let's just, I'm going to 2017, 4 is going to be 2018, 5 is going to be 2019, 6 is going to be 2020, 7 is going to be 2021, 8 is going to be 2022, 2022, 9 is going to be 2023, so 10, oh sorry, I was off by 1, 2024, and then 11 is going to be 2025. Okay, so we want to use x, so if we can just keep going in our table here. Okay, so let's do this. We're going to go, x is 11, so we're going to do 24 times 11 plus 70.2. So in the year 2025, we would expect the company to make $334,000. So let's go ahead and write that down. So you can say f of 11 equals, where did my equation go? 334.2, and rounded to the nearest hundredth, so we don't have to worry about that. And this is what you type into Desmos. Okay. If there are any questions, please send me a message. We'll go over this when I come back. Hopefully, I am back sooner than later. It's really frustrating. I'm hoping to get cleared by the doctor today to come back. I will see you all soon. Bye.